In cosmology and theoretical physics, the multiverse theory, which postulates that there might be multiple or even an infinite number of universes, is a well-established idea. Although the theory has been around since the late 19th century, its scientific foundations come from the study of cosmological forces and issues related to the Big Bang theory. Whether or not life could exist in multiple universes is one of the theory's biggest unanswered questions. What would it mean for life if the laws of physics changed from universe to universe? Stephen Hawking's final theory questioned the existence of the multiverse and suggested a finite and reasonably smooth universe in its place. What does this theory imply, and will the James Webb Telescope ultimately validate Stephen Hawking's multiverse theory? Oh hey, if you want us to feed you informative videos like these, please don't forget to drop a like on this video and subscribe to the channel if you haven't already. It is both a triumph and a tragedy that we view the universe from our modern perspective. The success is that we've learned so much about the universe we live in, despite being situated around a random star inside a common galaxy in a vast universe. Both the fundamental building blocks of reality and the laws that govern the cosmos have been identified. With observations spanning from the present to the far reaches of the universe, more than 13 billion years ago and more than 30 billion light years away in space, we've created a cosmological model that can explain how the universe came to be as it is. We've been pondering the nature of the universe for countless generations. Tragically, there is still much about the universe that we don't know. It's finally time for the James Webb Space Telescope, the highly anticipated groundbreaking newcomer to the pantheon of space telescopes, to make a splash. A welcome change from the waves its frequently delayed launch and ballooning cost have made. The launch of the telescope has now been delayed by a decade, and its cost has risen by roughly $9 to $10 billion over budget. But before starting to work, this powerful space telescope will need to go through several months of calibration and testing after a successful launch and deployment of its parts. It's because of the substantial 6.5-meter giant mirror that had to be folded during launch. Aside from that, the telescope will allow users to look inside the atmospheres of planets outside of our solar system. It is possible to see through enormous dust clouds to observe the formation of new stars and planetary systems. The JWST will have the ability to gather and reflect light from the early universe. JWST will be able to observe light from the earliest stars and galaxies close to the Big Bang, which are estimated to be 13.8 billion years old. As an infrared telescope, the JWST looks for objects in space by detecting infrared radiation. It is capable of observing celestial objects like stars, nebula, and planets that are too cool or too faint to be seen with the naked eye in visible light. Infrared radiation can also pass through gas and dust, according to NASA, which appears opaque to the human eye. When compared to the famous Hubble telescope, which can see visible light, ultraviolet light, and near-infrared light, this is different. The instruments on board must be kept at extremely cold temperatures, minus 370 degrees Fahrenheit or lower, in order to function. The substantial sunshade keeps the telescope cool and shields it from the sun's heat. In 2018, an independent review board produced a report that stated that there were 344 single-point failures or steps that needed to work for the mission to succeed. The telescope, however, was safely launched from the spaceport of the European Space Agency in French Guiana after being tucked inside the nose of an Ariane 5 rocket. It began operating in December 2021. Once the rocket was launched, it came apart and started to unfold. The solar panels began to unfold about 30 minutes after launch, allowing the telescope to begin receiving power from the sun, according to NASA. Numerous astronomers are competing for time with the JWST due to the telescope's capabilities. Astronomers were invited to submit proposals for how they would like to use the James Webb Space Telescope, with 6,000 hours of observation time available by the Space Telescope Science Institute, which manages science operations on Hubble and JWST. With approximately 20 years of operation guaranteed by the amount of fuel aboard the Space Telescope, the JWST has plenty of time to uncover the deep secrets of the universe. Will Stephen Hawking's theory of the multiverse be validated by the James Webb Space Telescope in the end, now that the JWST has been safely transported to its destination, which is approximately 1 million miles from the Earth? It is time to verify one of Hawking's most fascinating theories, the multiverse concept. Just 10 days prior to his passing, the paper he co-authored with Thomas HERTOG, a physicist at the Catholic University of Leuven in Belgium, titled Smooth Exit from Internal Inflation, was submitted for publication. There may be some unanswered questions regarding Hawking's theory of the universe's creation. The scientists behind the JWST will likely be contenders for the Nobel Prize if it ultimately contributes to the proof of the multiverse's existence. However, Hawking would not be qualified to receive the Nobel Prize because it cannot be given posthumously. Let's look at what Hawking's multiverse theory is and what did the late scientists have to say about it. According to the multiverse theory, our universe, which spans tens of billions of light years and contains hundreds of billions of galaxies and virtually innumerable stars, may not be the only one. Alternatively, there could be a completely distinct universe and then another and another, all situated far away from our own. This novel theory postulates the existence of an infinite number of universes, each with its own set of physical laws, stellar and galactic formations, and perhaps even intelligent civilizations. Theoretically, our universe may only be a small portion of a much grander, much larger collection of universes known as a multiverse. The existence of doppelgangers or copies is implied by the multiverse, which makes it, as some people say, creepier. The same patterns are destined to repeat eventually if there are an infinite number of universes, but a finite number of configurations for particles in each universe. Additionally, there would be an infinite number of these precise scenarios occurring simultaneously because there would be an infinite number of universes. The multiverse concept appears in a few areas of physics and philosophy. The inflation theory, however, provides the most notable example. According to the inflation theory, a hypothetical occurrence took place when our universe was incredibly young, less than a second old. During that brief period of time, the universe experienced a period of rapid expansion that caused it to balloon to a size that was many orders of magnitude larger than it had been before. Approximately 14 billion years ago, our universe's inflation was thought to have come to an end, but not everywhere sees an end to inflation at the same time. Inflation may continue in some areas as it does in others, as some regions experience a decrease. Inflation may have continued in other much farther off regions as it ended in our universe and may still be doing so. The creation of numerous separate universes in an infinite sea of internal inflation is caused by the pinching off of smaller universes from larger expanding universes. Each universe would emerge from this hypothetical scenario of internal inflation with its own set of physical laws, particle configuration, force configuration, and values of fundamental constants. This may shed light on the characteristics of our universe, especially those that defy simple physics explanations like dark matter or the cosmological constant. The existence of life, especially intelligent life, capable of making cosmological observations, is considered by some scientists to be the strongest evidence for the multiverse. According to their perspective, certain characteristics of our universe, such as the longevity of stars, the abundance of carbon, the accessibility of light for photosynthesis, and the stability of complex nuclei, appear unique and essential for supporting life. However, if you are given a random universe, you are unlikely to find all these characteristics. The existence of other universes provide one explanation for why all these characteristics are advantageous in our universe, but since it can sustain complex life, we continue to observe this one. HERTOG claimed that Hawking was not content with his current level of comprehension of the multiverse, so he invited her dog to join him in an effort to tame the universe. The two then set out to devise a strategy for turning the concept of a multiverse into an orderly, verifiable framework for science. In his paper, Hawking outlines a framework for understanding the cosmos that would make the multiverse finitely measurable and amenable to meaningful engagement with the aid of scientific methods. Intriguingly, Hawking acknowledged in an interview that he had never been a fan of the multiverse despite having contributed to the theory that gave rise to the concept of infinite parallel universes, the eternal inflation theory. Scientists think that although this is still just a model, it might be tested soon. According to them, the James Webb Space Telescope was created specifically to provide answers regarding the creation of stars and galaxies. In addition, the Laser Interferometer Space Antenna, LISA, one of the gravitational wave detectors in the next generation, is expected to reveal a lot more information about black holes, including primordial ones, if they exist. According to astronomers, the two observatories should provide them with enough data when combined with piecing together the history of the first stars and perhaps the beginning of dark matter. What do you think about the multiverse and the James Webb Space Telescope? Drop your thoughts in the comments section. Also, make sure that you like this video and don't forget to subscribe to our channel to stay updated about the latest videos.